Yesterday, 9th point I discussed or 8th point? 9. Okay. So 10th point. If C bar is coplanar with C bar is coplanar with A bar and B bar with non-parallel vectors A bar and B bar, then there exists real numbers lambda comma mu such that C bar is equal to lambda A bar plus mu B bar. Yesterday I explained this at the last that in a plane, if there are two vectors A bar and B bar, any other vector in this plane can be written as a linear combination of A and B. I told you how you can construct a parallelogram where these two sides are parallel to A bar, these two sides are parallel to B bar. This is a multiple of A bar, this is a multiple of B bar. They are summed by parallelogram like this. Okay, so that is this point. Once you know two vectors in a plane, every other vector in this plane will be some multiple of first vector plus some multiple of second vector. Lambda can be positive number or negative number, mu can be positive number or negative number. If A bar, B bar, C bar are three non-coplanar vectors, if A bar, B bar, C bar are three non-coplanar vectors, then any vector D bar in space can be expressed as a linear combination of A bar comma B bar comma C bar. That is there exists lambda mu gamma real numbers such that D bar equal to lambda A bar plus mu B bar plus gamma C. Some people may not be able to read what I am writing. Those are online. Am I audible?
Yes, sir.
Okay.
Yes, sir.
So I am reading 10th point once again. If C bar is coplanar with the non-parallel vectors A bar and B bar, okay, non-parallel vectors A bar and B bar, then there exists real numbers lambda and mu such that C bar equal to lambda A bar plus mu B bar. That is, we are able to express C bar as a linear combination of A and B. Similarly, if A bar, B bar, C bar are three vectors which are not in one plane, they are in space, then any other vector, any vector D bar in space can be expressed as a linear combination of A bar, B bar, comma C bar. That means there exists three real numbers lambda, mu, gamma such that lambda into A bar plus mu into B bar plus gamma into C bar will be D bar. In fact, this is the reason we take every vector in the space as xi plus yj plus zk and every vector in xy plane as xi plus yz. till 11th point? Okay. Now whatever section formula that you studied in 2D geometry, that you studied in 3D geometry, same section formula is there in vectors. I will not just tell the formula and say because it resembles that it is easy. I will tell you the proof also. If MB is midpoint of AB, then position vector of M, I told you what is position vector. Join origin to that point. If you want position vector of P, it is OP bar. If you want position vector of M, it is OM bar. O is origin, M is one point. OM bar is equal to OA bar plus OB bar by 2. That is position vector of M is position vector of A plus position vector of B by 2. And in the place of O, you can write any name. You can write P, Q, L, doesn't matter. LM bar, you can write LA bar plus LB bar by 2, or PM bar, you can write PA plus PB by 2. After all, O is just one point. In the place of O, you can write always any other point P or Q or R or S. Okay. Let me explain how this came. It looks like a regular midpoint formula, right? In 2D geometry, if x1, y1, x2, y2 are 2 points, then midpoint x coordinate is x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Something this similar to that. Okay. How to prove? Let us say this is origin, this is point A and this is point B, this is M midpoint. OA bar is called position vector of point A and OB bar is called position vector of point B. How to find OM bar? That is our question, where these two lengths are equal. M is midpoint. Okay. There are two ways to understand this formula. One is I can write AM bar equal to MB bar. Why? AM and MB have same length. AM bar is also like this, MB bar is also like this. If two vectors have same magnitude and same direction, they are equal vectors. So I can write like this, right? This AM bar I can write OM minus OA. I told you, whenever you want a vector, it is position vector of the second point minus position vector of the first point. Yesterday I told you AB bar equal to OB minus OA when I defined position vector. Okay. This MB bar I can write OB bar minus OM bar. Position vector of the second point minus position vector of the first point. Okay. Bring this OM bar this side, this OA bar that side. You will get 2 OM bar is equal to OA bar plus OB bar. Divide with 2, you will get this. Okay. Another way is parallel to this you draw one line, parallel to this you draw one line and extend this. Now, is this a parallelogram? If this is OA bar, this is OB bar, from here to here, what is the vector? OA plus OB. But this is half of that. OA plus OB by 2. That's it. Right? So if I want to call this point as L by parallelogram law, okay, this is one method. Another method is method 2. OM bar is actually OL bar by 2. OL is nothing but by parallelogram law. OA bar plus OB bar by 2. You can explain this way or you can explain this way. Now, in the place of O, you can write P also. PA bar plus PB bar. If P is here, will be PL bar. Half of that will be PM bar. That's how we can explain this. So, whenever I tell any formula in terms of O, in the place of O, you can write P or Q or L or any name. That doesn't matter. But it is easy to remember because you have this regular section formula. If you know position vector of this, and if you know position vector of this, position vector of the midpoint is this position vector plus this position vector by 2. Okay, please write this point with this explanation. the general section formula, if there are 2 points A and B, and P is a point on the line segment AB dividing AB in the ratio m is to n, the position vector of P is m into position vector of B, n into position vector of A by m plus n. It is like mx2 plus nx1 by m plus n. That section formula only. Okay. So this is a formula. Again, in the place of O, you can write any other name. Doesn't matter. Okay. How this one has come? I can write AP bar by m equal to PB bar by n. From this, I can write n into AP bar means OP bar minus OA. M into PB bar is OP bar minus OP. So I will get n OP bar plus m OP bar equal to n OP bar plus n OA bar. You can take OP bar common and divide. You get OP bar is m into OP bar plus n into OA bar by n plus n. Because this length is proportional to m and this length is proportional to n. If I take AP bar by m, PB bar by n, they will be equal. It is like unit vector in this direction, unit vector in this direction. It is not, we cannot write like this, it will be wrong. AP bar by PB bar, you cannot write m by n. AP length by PB length is m by n, but there is nothing called division of vectors. We did not define one vector by another vector. What is that? Is it a vector or scalar or something? We did not define. That's why I have to write like this. Okay? And then AP you can write OP minus OA, PB you can write OP minus OP, rearrange it, you will get this section form. So it is very easy to remember this formula and this formula. This is a regular midpoint formula, regular section formula. But how it came in vectors, I am just telling you the proof. Those are online, are able to follow?
Yes, sir.
Yes, sir.
Yes, sir.
So today AC temperature is okay for you? Still cool? Still cool. Okay. Should they put 26 there? 24. No, they kept it 24. Should they keep 26? Maybe some people are from the childhood, they are even born in AC rooms and always living in AC rooms, I guess. Actually, the buildings are constructed in such a way that there is a very good ventilation. There is a cross flow of air and all. We don't need ACs actually. Okay, maybe in a summer hardly for 6-7 days when the temperature is very peak. Okay, otherwise we don't need frankly. But nowadays the buildings are such a way that we don't have windows this side. We cannot open the windows. So actually, from my childhood till 1 or 2 years back in my house, there is no AC. Okay, just 1 or 2 years back we purchased. I don't want to purchase, but in my family somebody wants, and that too in a year hardly we use it for 5-10 days in summer. Otherwise, we don't use it. Luckily, in my house there is a very good ventilation, so I never felt a need. Okay, and And frankly, it seems many people told me that those are in the medical field. In summer, experiencing that temperature is actually good for our body. It removes the toxins from our body in the form of sweat and whatever it is. Okay, and by nicely living in AC rooms, okay, we are keeping toxins nicely in our body and getting lot of diseases. Okay, and if you have maintained this due to all these emissions from the vehicles and factories and all, whatever temperature we at least increasing by 5-10 degrees centigrade, at least 5 to 7 degrees centigrade. Okay, if that was not there, there was no need of these ACs. Okay, so once you have this section formula, other things follows. For example, if there is a triangle ABC and this is a median where these two lengths are equal, this is a median where these two lengths are equal, this is centroid G. Formula for OG bar, guess what it will be? Quotient vector of the centroid. OA bar plus OB bar plus OC bar by 3. Quotient vector of A. Normally it is x1 plus x2 plus x3 by 3. So like that, OA bar plus OB bar plus OC bar by 3. This is a very simple regular application. Normally we will find this point and dividing the ratio 2:1, we will get this point, we will get this. In Tuesday class, we will do IP first exercise in the class itself. Okay. Then we will know what is the application of all the things that we learned. Okay. So if somebody has few doubts here and there in the theory, don't worry. Okay. Through the questions, it will be clear. Okay. If there is a tetrahedron, okay, this is not a two-dimensional figure, three-dimensional figure. A, B, C are on the ground, D is somewhere in the air, such that A, B, C, D is a tetrahedron. Okay, tetrahedron also will have one centroid. What is that? Triangle ABC will have one centroid joined to D. Triangle BCD will have one centroid joined to A, and triangle ADB will have one centroid and joined to C. Similarly, triangle ACD will have one centroid and joined to B. There will be all these medians are concurrent. Median of a triangle is different. Median of a triangle is line joining one vertex to the midpoint of the opposite side. But what is median of a tetrahedron? A line joining one vertex to centroid of the opposite triangle. Okay. Like that, there will be 4 medians from one vertex to the centroid of the opposite face. Those 4 medians are concurrent. Like here, centroid divides each median in the ratio 2:1. Here it will divide in the ratio 3:1. Okay. This will be 3 parts and this will be 1 part. Okay. Now there is a formula for the centroid G. This also we call G. That is OG bar is OA bar plus OB bar plus OC bar plus OD bar by 4. In 3D geometry, we will study it as x1 plus x2 plus x3 plus x4 by 4. First of all, we find this centroid, apply section formula 3:1, we will get this. Okay. So this is centroid of triangle, this is centroid of tetrahedron. basically for first and second exercise only this much, but I have to talk about equation of line and equation of plane. Okay, we'll come back to that, but with this we can do some questions. In vector algebra, there will be few questions. They can be done by pure geometry. They can be done by vectors or some other methods also. Let me see if somebody has done some kind of question like this in school level. Let us see if you can answer this. This is a triangle. Any triangle, scalene triangle. You divide. There is a point dividing this in the ratio. Let us say 7:3. Okay. Divide BC in the ratio 7:3, and let us call that as some L. You join that. Okay. Take another point here or here, no problem. Let us say this is any ratio, take it, not a problem. Okay. Let us say 2:1. Okay. Any ratio, 3:1, 5:1 to 9:2 take and join to this. I will call that is M. So L is dividing BC in the ratio 7:3, A and L are joined. M is dividing BA or okay, in the ratio 2:1, join them. Now this point I want to give some name and I want to join this. Let us call this is L, this is N, I will call it. This is M, and I will give some name for P. Okay. Now only two data is given for us. BL is to LC is 7:3, BN is to NA is 2:1. Now they want what is AM is to MC, or what is AP is to PL, what is BP is to PM, or what is CP is to PN. They can ask any lengths. Okay. Anybody want to have any idea about how to find AP is to PL? AP is to PL, or how to find CM is to MA, or how to find BP is to PM? Either this is to this, or this is to this, or this is to this, or this is to this. Any one of them. Anybody any idea? Those are online or offline? Anybody has done some question like this before? You had any name called Menela's theorem? Seva's theorem? In straight line chapter, in 2D geometry, you will find Seva's theorem and Menela's theorem. I think even in IP textbook you will have Seva's theorem proof that a line divides two lines, line segment in the ratio -L11 is to L22. Okay. Anyway, so this question, by using pure geometry, using Seva's theorem or Menela's theorem, it can be done. Okay. It can be done by vectors. Okay, we will discuss by vectors. Okay. But I was teaching this question, that means it is a regular question in our mains material also, it will be there in vector somewhere. Okay. Somehow 2 years back, exact 2.5 years back or 3 years back, suddenly when I was teaching, I got one excellent idea. Okay. I did not try like Eureka and all that, but it was a very beautiful idea. I shared with some teachers, they also liked it very much. Okay. The method I will tell you, I ask different ratios now. All of them you can tell just like that. You don't have to write anything so much. Very simple. But I am going to use little bit of physics. Okay. Let us say I get a mass of 7 kg here and a mass of 10 kg here. Okay. For these two, there will be some center of mass somewhere. Correct? Okay. This length into this length. Okay. What will be the ratio? If for these two masses, center of mass is here, this length into this length, what is the ratio? It will be 10:7. Center of mass will be more closer to the heavier mass, right? Okay. Why it is 10:7? Very simple. With respect to center of mass, the torque of this and torque of this should be same in opposite direction. So if this is L and this is M, L into 7 equal to m into 10, right? About this, the torque in clockwise is m into 10, the torque in anti-clockwise is L into 7. You will get L by m equal to 10 by 7. You can say that, right? Okay. Now, let us say I have a triangle ABC. I will put a mass of 2 kg here and some 9 kg here and some 4 kg here. How will I find the center of mass? Okay, I may have a formula m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Similarly, m1 by 1 so on. Without all that, I want to do something else. The center of mass of these two, okay, will be here. Then I can remove this mass and put a 13 kg mass there, right? That's what center of mass after all means now. Remove these two masses and put 17 kg there. No change will happen in the forces or torque, right? Okay. The system should not change basically. Okay. So if I had 9 and 4 here, I should put 13 kg here. But where should I put 13? This length is to this length. I think 9 was here and 4 was here. Okay. This length is to this length should be 9 is to 4, the reverse ratio. Because more is the mass, center of mass is closer to that. So if this is to this is 9 is to 4, I can remove this and put 13 kg there. Then, how will I find center of mass of these two? Remove these two and put a mass of 15 kg here. Such a way that this length is to this length will be what? 13 is to 2. Okay. So back to again, this is 9 and this is 4. Okay. So this is 13 is to 2. But one may say, why are you first remove these two masses? I want to do different. I want to remove these two masses. Yes, you can do that. And earlier I got center of mass here. Okay, now for these two center of mass will be here. I have to put 11 kg and remove this 2 and 9. Now this is 4 and this is 11. On that line, you take 11 is to 4. I can remove 4 and 11, put 15 there. I get same center of mass. Or back. What are the masses I took? I think I took 9 here, 4 here, 2 here, right? Why that? I want to remove these two masses and put a mass of 6 kg here. Where this is to this will be 4 is to 2. And this is 6, this is 9. So I can put a 15 kg mass where it will be 9 is to 6. So there are 3 ways to find center of mass position. That is, first remove these two masses and then find center of mass of these two. Or first remove these two masses and find center of mass of these two. Or first remove these two masses and find center of mass of these two. Am I correct? Okay, this I am going to do in reverse now. If I want to have center of mass here, I can tell basically in a triangle if I put mass here, mass here, mass here, center of mass can come anywhere inside. If this mass is heavier, center of mass will come this side. If this mass is heavier, center of mass is this side. And if this mass is heavier, it will come this side. By changing the mass here, mass here, mass here, I can make sure the center of mass is here, 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 anywhere, right? Okay. Now if I want center of mass here, what should I do? Let us see. Because this is 7 is to 3, can I say I should put 7 kg here and 3 kg here? Opposite ratio, right? Okay. Now because this is 2 is to 1, I should put a mass of 1 here and a mass of 2 here. But I kept mass 3 kg, so I should keep how much mass here? 6. Okay. So now I got 7 mass here, 3 mass here and 6 mass here. If I remove these two, I will be putting 10 kg here. If I remove these two, I will be putting 13 here. If I remove these two, I will be putting 9 here. Correct? Okay. And finally 9 plus 7 is 16, 3 plus 13 is also 16, 6 plus 10 is also 16, right? That's it. Now you want, you can tell any ratios. You tell me this is to this, what will come? 7 is to 6. What if this is to this will come? 10 is to 6. What if this is to this will come? 13 is to 3. And what if this is to this? 7 is to 9. Question done. We are able to tell all the ratios just like that. Once you put the masses. Clear? Okay. Anyway, later on we will discuss 1 or 2 questions. The basic point is, based on these ratios, put masses so that the ratios will be satisfied. For these two, center of mass should be here. For these two, center of mass should be here. Once you give the masses, find what should the mass here, sum of these two. What should the mass here, sum of these two. What should the mass here, sum of these two. Sum of these two and sum of these two and sum of these two all will be same, it will be here. Once you know that, you can tell any ratios. Okay. In fact, in pure geometry, there are questions like this length by